Hello, everybody. I'm going to go ahead and do another problem from your textbook, section 4.7, number 21. Find the point on the line. Find the point on the line y equals 2x plus 3, closest to the origin. Closest to the origin. Okay. So let's say if this is x and this is my y-axis, and let's say that 0.00 origin. Okay, the line y equals 2x plus 3, the y-intercept is going to be 3, 1, 2, 3. So I have a point right here. When x is 0, y is 3. When y is 3, when y is 0, x is going to be -3/2. So somewhere here, -3/2. So this is going to be my linear line. And there's a point in that, located on that line of 2x plus 3 that has the shortest distance to 0, 0. Okay, where is that point? So many times students think that that would be this point right here, since they think that the straight line is the shortest distance, but actually it's not true, because if you are looking this a little bit, if you walk around this and look at it, there must be a point somewhere up here that is shorter, somewhere in there that is shorter. Okay. So how can we just go about this? We know that I can use a distance formula to find the distance between the origin, but I have to have the coordinates of the other points. The coordinates of this point here that I'm guessing it's right there. The x coordinate is, of course, x, and the y coordinate is f of x, so 2x plus 3 is the location of that point. Okay, so going to the next page, we know that distance equals to square root of x minus x1 quantity squared plus y minus y1 quantity squared. We learned that in pre-calculus. Okay, so let's plug in numbers. X minus my x1 is going to be 0, quantity squared, plus y, and we said y was 2x plus 3 minus 0, quantity squared. Now let's just simplify that. So d equals square root of x squared plus, I have 2x plus 3, quantity squared. So d equals to, let me change color, square root of x squared plus 4x squared plus 12x plus 9, and finally d equals square root of 5x squared plus 12x plus 9. Now, let me fix this plus 9 right here, plus 9. Now, I know that we can write this as, let me go to the next page and write this as d equals to 5x squared plus 12x plus 9 to the power of 1/2, and take d prime from there. But usually not all the time in mathematics, when I have something like this, what we can do, we can say that, okay, say let some alphabet, let's say let some t equals to d squared. And if d equals to this, then d squared should equals to 5x to the second plus 12x plus 9. And so t prime equals to 10x, okay, plus 12, say it equal to 0. Then we have 10x plus 12 equals to 0. 10x equals to negative 12, and x equals to negative 6 over 5. And that is my critical point. So that is my critical point. Okay, let's go to the next page. All right. So here is, I'm going to now test that critical point. Test numbers to the left and right. Here's my negative 6 over 5. If I plug in the values to the left of negative 6 over 5 into my t prime, I get negative values in here. To the right, such as plugging 0, of course, I get positive values. So notice that the slope of slopes of the tangent lines are decreasing, turning around and increasing. So at negative 6 over 5, I have a minimum. So my min is at x equals to negative 6 over 5. Now, all I have to do is find the y value for that. So I can say that we know from that y equals to, from the previous page, 2x plus 3, the original problem that we had. So that equals 2 times negative 6 over 5 plus 3. And that equals to negative 12 over 5. And 3, I'm going to write it as 15 over 5 to have least common denominator. So that gives me 3/5. So the point that has the shortest distance to the origin located at that line is negative 6 over 5, comma 3 over 5. Hope you like this video. I'll do more for you. Thank you.